Okay. All right. So this is, yeah, again, this is a section. Oh, sorry. I need to turn on my pencil. All right. So this is a section 4.1, right? The scatter diagram. And linear correlation. All right. So no. So first we discussed, of course, the how to graph scatter diagrams, right? And then we said there is a numerical measurement, sample correlation coefficient that describes the strength of the linear linear correlation, right? So the idea here, guys, so we use this number R. So we use the sample correlation coefficient R to describe the strength of the linear correlation. All right, so we said, just to remind you what we said yesterday. So so in general, so if your R, so we said R is always between -1 and +1, right? This number R. So R is always between -1 and +1. And then we said, so if R is +1 or R is -1, then we have a perfect linear correlation, right? So then all the points, they're gonna lie on the same line, right? So the scatter diagram would be like, it's gonna look like something like this here. So where the points of your scatter diagram, when you plot your points, then all the points, they're gonna lie on the same line. Okay, so that's what we call perfect linear correlation, right? Now, if your R, so we said if this number R is close to + or -1, then we do have a strong. So if R is close, right, to +1, or there's a question in the chat. Let's see, there's something in the chat. Hi, Gabriela. I got you. Thank you. Yeah, so if R is close to 1 or R is close to -1, right, then we have actually strong. So that's a strong linear correlation, right? So then, the point, not all the points are going to lie on the same line, but your data, your points going to resemble a line, right? It's almost perfect line. So so you have your points, and as I said, it's not a perfect line, but it resembles a line, right? So it's like so you have like something like this here. Okay, so so your points are very close to your line, right? So that's what we call a strong linear correlation. Now, if R, of course, is 0 or close to 0, so if R is close to 0, I mean, if it's 0 or close to 0, so if R is 0 or close to 0, then we have no or little linear correlation, right? So then So we have no or little linear or very weak linear correlation. Okay, so then the graph would be like, your scatter diagram would be like, you don't really have a linear correlation, right? So you have like your points are just a mess. It doesn't look like it's a line, right? Okay. And of course, if your R is like close to half, let's say, or close to negative half, then so if R is close to positive half, 0.5, or close to negative 0.5, close to negative 0.5, then we have like, so something which is, so it's not strong. It's not a strong linear correlation. It's not a little for a low linear correlation, but it's, let's say, it's moderate. Okay. So then we have a moderate linear correlation. Okay. So we have something like this here. Okay. And last thing, just to remind you, last thing. So the sign of R describe if the fact that your line is increasing, or is going up or going down, right? So if R is positive, then we have, if R is positive, then we have now then we have a positive linear correlation. So that's positive linear correlation, right? So again, means that the data is going to resemble a line which goes up. Okay, so we're going to have something like this here, for example. Right, and if R is negative, of course, then that will be a negative linear. If R is negative, then that would be a negative linear correlation.
Professor, so
Yes.
if R is negative, then
Yes.
that means we don't, oh no, we do still calculate R.
Oh no, you're gonna I mean, you're gonna calculate R in any way. I mean,
Okay.
you need to calculate R. I mean, like in standard problem, first question would be to make the. I'm probably gonna do like a standard problem. So in a standard problem, you would have to graph the scatter diagram, and number two, you have to compute your R, and then from the R, you need to describe the strength of your linear correlation, right?
So we get the R from the correlation if it's okay.
Yeah.
I get it. Okay. Well, this
so yeah, yeah. So yeah, so like when R is negative, then you have like a line which goes down. All right, so we had an exercise yesterday, and I didn't have time, of course, to do the exercise. But now let me just remind you the formula of R, right? So this formula of R is kind of scary. I mean, it's like a huge formula. So the formula of R. So and I'm gonna try to explain each term of this formula, right? Yesterday, of course, I tried to use like different steps to compute this R. But here's another way. I mean, to compute R. If you don't like the steps of yesterday's steps, we can. I mean, we can do it like in a different way. So formula of R. So R, we said R is actually equal. So this is first we have n, then times. So this n times sum of the x times y minus, and then there's a sum of the x's right? Then times the sum of the y's. Okay, that's the top. Now the denominator in r. So the denominator, it's a kind of a mess. So it's a product of two square roots. So there's a first square root, and in this first square root, so we have this again n times. Now this time it's the sum of the x squared. So sum of the x squared, all right, minus the square of the sum of the x's. All right, times, so we need to multiply. Now we do the same thing. So this is square root. Of course, square root covers everything, right? Everything is under the square root times. So here it's a multiplication. Times the same thing, but with the instead of x, we have r, right? So it's like n, and then there is a sum of y squared minus the square of the sum of the y's. So again, the idea here is that this r, this number r, I mean, it doesn't come from nowhere. This is just like the rate of change of your data values. Okay. Now, the way to compute this r, so in a standard problem, so we have this exercise yesterday, right? This example with where x is. So we said, so x represents. So this is this example again. It's from the textbook, as I said yesterday, exercise 14 from the textbook. So x represents the average number. That's the average number of employees in a group health insurance plan. Health insurance, sorry, insurance plan. Okay, that's your x. And then y is supposed to represent the average cost as a percentage of claims, as a percentage of claims. All right, so first, yes, let me just write down again the numbers. So x, y, I think we had like five data pairs, right? We have like 3. When x is 3, then we said y is 40. When x is 7, then we said y is 35. When x is 15, then y, the corresponding y is 30. When x is 35, then the corresponding y is 25. And then when x is 75, then the corresponding y is 18. All right, so first, we need to check. So first question here. So we need to check that using your calculator, you need to check that sum of the x's would be 135. Sum of the x squared would be 7,133, right? And then sum of the y's is 148. Then the sum of the y squared is 4,674. And then sum of the xy is 3,040. Okay. So, I mean, you need to check these numbers, right? And let me just explain each symbol here. So, like for number 1, right? So the sum of the x's. So when I say the sum of the x's, right? You take the values of x. Okay, so the values of x, like, so you have like 3, we have 7, 15. Those are the values of x, right? The numbers in the top. That's the values of x. So all I'm saying here, this is the summation, right? So you take this sum. So if you take the sum of, the numbers in the top, the values of x, the 3, the plus 7, plus 15, plus 35, plus 75, right? Now, I mean, if you use your calculator, I mean, here there's only one operation, right? Which is addition, right? So, so if you do this 3 plus 7 plus 15 plus 35 plus 75, right? Then you're supposed to get 135, right? That's the 135 here. Okay. Next, we need to check that the sum of the y's is 148. So again, sum of the y's, that's again, it's just the sum of the values of y. So the values of y are the numbers or the values in the second line, right? So they have 40, 35, 30, 25, 18. That's the values of y. Okay. So if you do 40 plus 35 plus 30 plus 25 plus 18 using your calculator, and again here is just there's only one operation here, addition, right? So if you do that, then you get 148. Next, we need to check that the sum of this x squared is 1733, right? So what's the sum of x squared? So you need to take the square of x, the square of each value of x. So like the first value of x is 3, right? So we need to take 3 square plus next value of x is 7, right? So we need to take 7 square. Next value is of x is 15, so we need to take 15 square. Next value is 35, we need to take 35 square, and then 75 square. And again, when we say square, it means you need to multiply the number by itself, right? So like 3 square, that's like 3 times 3, right? So this is saying like 3 times 3 plus 7 times 7, plus 15 times 15, etc. Okay, so of course here we have addition and subtraction, but PEMDAS rule, with the PEMDAS rule, of course, you need to do the multiplication first, right? You do the power first. So this would be like, 9 plus, 49 plus, 15 times 15, that's 225, etc. Okay. Now, if you do that, so what we are saying is then the answer would be this, the 7133. Next, we need to check the same thing, but now for instead of x, we have y, right? So this is just the same thing, but now it's with the values of y. So what we do is, so sum of the y squares. So first value of y is, well, as you can see, first value of y is 40. So we're gonna have like 40 square plus 35 square plus 30 square, etc. So we're gonna have, so this is first value of y is 40, right? So that's 40 square. Next value of y is 35. So that's, sorry, 35. Sorry about that. So 35 square plus 30 square plus 25 square plus 18 square. Okay. And again, the same thing, 40 square, that's 40 times 40, that's 1600, etc. And what we are saying here is that, so once you do the square, you multiply the number by itself, okay? But then you take the sum, and then the answer should be this 4,674. Now, last thing to check is that the sum of x times y is 3040, right? So this is, so sum of x times y. So we need to multiply x by y, right? This is x times y. So you take each value of x and you multiply it by the corresponding y. So like first value of x is 3, right? The corresponding y is 40. So we need to multiply 3 by 40. Next value of x is 7. We need to multiply it by its corresponding y, which is 35, right? So what we do is we multiply. So it's first x is 3 times corresponding y, it's 40, plus next x is a 7 multiplied by the corresponding y, which is 35. Next x is 15 times corresponding y, it's 30, 35, 5, and plus last x is 75, and corresponding times multiplied by corresponding y, which is 18. So as you can see, guys, I mean, here there are only two operations, right? There's addition and multiplication, but of course we do multiplication first, right? And yeah, so so we're supposed to check. Well, we are supposed to compute this thing here. Like 3 times 40, that would be 120. And then we have 7 times 35, that would be 245. Plus 30, that's 450, etc. Right? And
That's
then
kind of like what we did last week, right?
yes, like the for yeah.
Mhm.
You're talking about the standard deviation. Yes.
Yes.
It's similar to the standard deviation. Yes, you're right.
Okay.
And then take the sum, and then this sum is supposed to be equal to this number, right? This 3040. So that's the 3040. All right, we are done with this first. So this is like the first. That's like the first steps. So we are supposed to compute these numbers. Now, next, we need to plug these numbers in the formula, right? I think that's where it's kind of confusing. So let's go slowly here. So now we're gonna compute R. Okay, let's compute R. Okay, compute R. All right, so I'm gonna again write down the formula of R. Let me just write down again the formula of R. So R, we said this sample correlation coefficient R is, we said it's n, and then there is this the sum of x times y minus, right? There is the sum of the x's, sum of the y's times the sum of the y's over. So this thing here divided by, and then there are like two square roots. There's this n square root of times, I'm gonna just use a different color here. So n times sum of x squared okay, minus the sum, the square of the sum of the x's. So this is, take the sum of the x's and then you take its square. Now you multiply this. This is multiplied by the same thing, but instead of x, we're gonna use y. So we have n. There's the sum of the y squares minus the square of the sum of the y's. All right. First, in this formula, we have this n, right? There's this, as you can see, there's this n, right? So what's this n? N, that's supposed to be the number, that's the size of the sample. So in our case, that's the number of data pairs, right? So here, like how many columns, how many data pairs do we have? We have, any guess what will be the number of data, or the number, the size of the sample?
5.
5, right? So we have 1, that's the first column, second column, third, 4, and then the fifth column. So we have 5 columns, so that's 5 data pairs, so that's the size of the sample. So n is 5. All right.
How come it's not 10?
That's the thing. It's not. It's the number. That's the number of data pairs. A pair.
Oh.
It's not just like
So number.
x. A pair is x and y. That's why
Oh, okay.
the pair is
Okay.
given by X and Y.
So,
Okay.
and that's always the situation.
Yes, in this situation, when you have like these two variables, X and Y, you
Mhm.
count how many pairs. So how you count how many,
So
uh,
n is always gonna change. So let's say it's either if we have 10 pairs of the x and the y, like the number on the top, 30, 47, 35. Those lines, those pairs, here we have 5, yesterday was 10. So n will always change.
yes, of course, absolutely. So that's a good point. So the N depends on the sample. So it depends on the problem, depends on the exercise. So yes, as you said, yes, yesterday we had an example with the earthquake, the magnitude and the depth. And there we had, I think, N was probably 7 or so. Yeah, depends on the exercise, the N. So yeah, that's a good point. Uh, so uh, so here in this example, this N is 5. Okay, so let me just write down here. Let me just say that this N, this is the number of data pairs. And, or this is the number of, you count how many columns, okay? We have 5 different columns, right? Different values of X and Y. So yeah, so the N is 5 in this case. All right, so we got, let me just write down here our R. So this is 5. Now, what's the next number in the top? There is this sum of X times Y, right? So this is X multiplied by Y. Okay, so X multiplied by Y, well, we just said that will be this number here. This 3040, right? That's supposed to be X, the sum of X times Y, right? You see here, X, it's multiplied by the corresponding Y. So that's the sum of the X times Y. Okay, so the next number, that's the 3040, right? And again, it's right here, right? Here's the X times Y, 3040. Okay, so the next number here, so that's 5 times multiplied by 3040. So far, so good. Okay, now minus next number. There's the sum of the x's.
The 135.
Absolutely, thank you. So sum of the x's, as you can see, it's the 135, right? That's the sum of the values of x, right? That's a 135. So here, oops, sorry about that. So it's minus 135 times, next we have the sum of the y's, and that will be sum of the y's.
148.
148, thank you. So right here, right, this is the sum of the y's. So sum of the values of y. So that's 148. So here times 148. All right. Now the denominator. So we need to go. We need to be careful with the denominator. Okay. So there's this square root, and then the first thing in the square root is we have n, right? Which is, we know it's 5, right? So there is 5 here times, and then we are supposed to multiply the n by the sum of the x squared, right? You take the sum of the x squares. So the x squared, it's right here. You see the sum of the x squared. So like you take the square of the first x plus the square of the second x plus the square of the third x, etc. And we got 7,130 feet, right? That's the sum of the x squared, right? This number right here, 7,130 feet. So, so it's 5 times 7,130 feet. All right, now where I think it's kind of confusing, minus, this is next, it's not the sum of x squared, it's the square of the sum of the x's. You know, because you're supposed to do the sum first and then take the square. So you see here inside the parentheses, we have the sum of the x's, right? So let me just write down my parentheses. So inside my parentheses, I have the sum of the x's. So sum of the x's, that's like first value of x plus the second value of x. You know, this is my sum of the x's. First value of x plus second value of x plus third value of x, etc. And that will be 135, right? This number right here. So here inside my parentheses, I have 135. This is 135. But then outside the parentheses, there is a square. Okay. So you see the difference, guys. I mean, that's I know it's from my experience. I know this is kind of confusing. That's where most of the students make mistakes. So there is a difference between, you know, this number right here, the sum of the x squares, and this one here, where you take the square of the sum of the x's. All right, now you're supposed to multiply. So this thing here by. And now we're gonna take the same thing, but instead of x, we're gonna have y, right? So first, there is this n again, which is, we know it's 5 times, and then we have the sum of the y squared. So you take the first value of y squared plus second value of y squared plus the third value of y squared, etc. So that's this number right here. You see right here, the sum of the y square. So square of the first y plus the square of the second y, etc. So the answer is this number right here. That's the 4,674. So 4,674. So 5 times 400. Sorry, 4,674. Minus. And then you see here, you see the square. The thing is, the square is outside the parentheses, right? That's different from this one here, right? Here, the square is, you see this square? The square is inside the parentheses, right? Now you have a square which is outside. So first, we need to do like, you know, in the PEMDAS rule, first thing is the parentheses, right? So inside the parentheses, what we have is the sum of the y's. Okay, so sum of the y's, that's the like, first value of y plus second value of y, etc. So that's exactly this number, right? This one here, right here, the first value of y plus second value of y, third value plus third value of y, etc. So the answer is 148. So here inside the parentheses, we have 148. This is 148. Okay, and then there is this square outside. And the thing, guys, is everything is under the square root. Okay, as you can see, I mean, everything is under the square root. All right, now how do we compute this this huge this huge fraction, right? First, let's do the top. Okay, the top is, I think it's not really hard. The top, I mean, in the top, as you can see, we have two operations, right? There is a multiplication and then there is a subtraction, right? So of course, PEMDAS rule says, well, first you need to do multiplication, right? So let's do the multiplication in the top, right? So like we have these two numbers here. So 5 times 3,040, which is 15,200. So this is 15,200. Okay, I just multiplied the 5 by the 3,040 minus. Now we need to multiply. And so next here, so we need to multiply 138 by you know, the 8. Okay, so it's just a multiplication here, guys. 135 by 148, so that will be equal to, of course,
19,000.
19,000. So
980.
Thank you, 19,908. All right. Now, let's see what happens in the denominator. So we have, again, this square root. So again, in the PEMDAS rule, guys, first you have the parentheses, right? Then you have the exponent, right? You think of the square root, a square root, it's an exponent, right? The square root, that's like a power half, right? When I say, when I say like the square root of 4, that's like 4 to the power half. So a square root, that's like exponent. Anyway, so what I'm saying is, like in the PEMDAS rule, you have parentheses, exponent, right? And then you have multiplication and division, right? And then addition and subtraction. So first we need to do the multiplication here under the square root. So there is the two numbers here. You see this 5 times 7,133, right? So we need to multiply, right? So that's 7,133 by 5, okay? So that'll be equal to 35,665 minus. And then we need to do the 135 square. You see this 135 square? So that's like 135, this is like 135 times 135, right? So that's equal to, let me see my notes, 135 times 135. So that's 18,000, oops.
18,225.
Thank you. So it's 18,225. So both numbers, guys, both numbers are under the square root, okay? All right, times, and then there's another square root. So we need to do this 5 times, you see this 5 times the 4,674, 5 by 4,674. So that'll be equal to 23. So this is 23,000, I think, 370 minus, and then there is this 148 square. That's 148. That's 148 times 148. Okay, if you don't know how to do the square with your calculator, I mean, you can just multiply 148 by 148. Okay, so that's equal to actually 21,000. Oops, I'm gonna just use the same color here. So 21,904. Okay, we are not done yet. So now let's finish the top. I mean, the top is just subtraction, right? So you have this 1,500.
Professor, I was going to ask. I'm sorry. I
Yes.
don't. I,
Yeah.
I
No.
know
No
you're going
problem.
through the steps. I want to make sure that when we do the top, we do it on that same order. We don't switch the numbers, because if you subtract 15,200 minus
That'll be negative.
19,908, it will be a negative number.
Yes. Yeah. Don't switch
Okay.
the numbers. Yeah. Don't switch the
Do
numbers.
not switch the
because,
numbers.
yeah. Yeah.
Okay.
Because R can be negative.
Okay. I just
Yeah.
Okay. I just want to make sure we don't have to
Yeah. You're right.
switch the larger number on top or anything like that.
That's a good point. Yep. So yeah. So actually, this answer, the top would be negative 4,000, I think, and 780 divided by. All right. Now we have these two subtractions under the square root. So we're gonna do the first subtraction. The first subtraction under the subtraction under the first square root. This one right here. Right. So we do the 35, 1,665 minus 18,225. So that's actually equal to 17. So this is 17,440. And don't forget, there is still the square root, right? So the square root, this is like the last thing you do. Times, And the same thing on the other, the second square root, right? So this thing here, so we do this, subtraction, right? This 23,000, 370 minus the 21,904. Let me just check my numbers. Yes, so that's 1466. Okay, so this 1466 is under the square root. All right, now next, now we do the square roots. Okay, now we do the square, we compute the square roots. Square roots. Okay, so we have this r, which is negative 4,780 over, and then we do the square root of the first number, right? The square root of 17,440. Okay. If you don't know how to do the square root with your calculator, guys, please let me know. Right. This is like the same thing with the standard deviation, right? We had to compute the square root of the final step. So yeah, so this is actually this is 132.06. Let's say times. Now we have a second square root. So square root of this. Let me just circle this thing here. That's my first square root, and then now we have a second square root. This one right here, the square root of 1,466. Right. So that's actually 38. So this time 38.28 or 29 if we round. All right. Okay, now next operation, we need to finish the bottom. So we need to multiply. So we have this negative 4,780 in the top, right? And then we need to multiply this 132.06, by this 38.29, right? And the answer is actually 5,056.36. Now, once you multiply the numbers, the two numbers in the bottom, now we can divide. Okay, now I can divide the top by the bottom. That's like the last step. So here we can divide this negative. So the answer is going to be negative, right? And the answer is negative 0.945. Right? We divide, just divide, divide, sorry, divide this 4,780 by this 5,056. So yeah, so as you can see, yes, please.
For calculator, but I know how to use the calculator. So at the first time I type all the number in the calculator and I find the same answer as you. So can I do that? Like if you give me a homework, or you need to see all the steps to find the error?
No, I don't. Now for the computations, no, I don't really need to see all the steps. But I mean, how do you enter all those numbers in the? Do you have like a special function to compute the R? I don't think that.
No, I don't know. I don't have that. I just use the calculator. I do. I put a fraction on the top.
Okay.
I put everything, and the down I put everything.
Oh, you mean like you enter all the numbers and then? Yeah, no problem. Yeah, if you can do everything in just one step, that's fine.
Okay.
Yeah, just so in the test or in the like in the test or the homework on the final, on the formula of R. So just saying, well, I'm using this formula, right? And then, yeah, if you know how to compute this R, like just one step, yeah, just write down the answer and that's fine.
Okay, thank you.
Yeah, so as you can see, guys, this R is negative. And again, if you get a number which is not between -1 and +1, I mean, this is, on the number line, there's this -1, there's this 0, there's 1, right? So of course, negative, like negative 0.94 this is very close to -1, right? This is, here's your -0.94, right? Very close to -1, right? But anyway, all I'm saying is if your answer is not a number between -1 and +1, then you're probably made a mistake somewhere, right? So anyway, so the conclusion here is that, so my R, so why we are doing this, why are we computing R? Well, so this R, so conclusion, so our R is very close. R is very close to -1, right? So if you are very close to -1, then we said we have a strong, you see right here, oops. If R is close to -1, then we have a strong linear correlation, right? And because it's negative, R is negative, right? It's a negative number, then our linear correlation is actually a negative linear correlation, right? So it means our line goes down, right? So what we can conclude here is that, so R is very close to -1. So then we have a very strong, it's not perfect, because in order to be perfect, R needs to be equal to exactly -1, but it's not -1. It's very close to -1. So then we have a strong negative linear correlation. And what does it mean to have a negative linear correlation? So negative means that as X increase, Y decreases. Right? That's what we mean by negative, right? The line is going to go down. So the values of Y, they're going to go, they decrease, right? So as X increase, Y decrease. If it was positive, then as X increase, Y would increase, right? But this is negative, so Y has to decrease. So in other words, what's X? X is supposed to be, X is supposed to represent the average number of employees, right? And the Y, so what we are saying here is that as the number of employees increase, as the number of average number of employees increase, so number of employees, that's the variable X. Variable X represent the number of employees. So as number of employees increase, right, the Y decrease. And what's Y? Y is supposed to represent the average cost, right, as a percentage of claims, right? Then the average cost decreases. Average supposed to be the average cost, which is supposed to be, which is represented by the variable Y, decrease. It's variable Y decreases. Okay. So again, the idea, guys, here, once you compute your R, this sample correlation coefficient, then you need to, you need to conclude, right? You need to comment the value of R. So if R is close to a positive or -1, if R is close to 0, etc. So like in this case, it's very close to -1. So we have a negative, very strong linear correlation. So again, linear correlation, guys, means we have a straight line relationship between X and Y, okay? So the variables X and Y, they change at a constant rate, okay? All right, so you know what, guys, because I know this is kind of, I mean, this computation is not really easy. So what we're gonna do, we're gonna do another exercise, and I'm gonna give you some time to compute this R. Okay, just make sure that you get the right answer. You don't have to compute the sum of the X squared or the sum of the Y squared, etc. All you have to do is just to plug the numbers in the formula of R and try to try to compute this R. So let's do an exercise. We can pick an exercise, I guess, from the textbook. Or you know what, we can just I don't want to have like the very large numbers. Let me see if there's anything here from the textbook that's not really okay. All right, you know what, we can do um, the the example we had. You know, the X supposed to represent so X supposed to represent you know, the magnitude of the earthquake. And Y supposed to represent the depth in kilometers, of course. Depth of the earth. All right, so we have the following numbers. We have a sample of size 7. So we have this 2.9, 1, 2, 3, 4, 5, 6, and 7. So 5.0. Then we have 4.2. We have 10. Then we have 3.3. Then we have 11.2, 4.5, 10. Then we have 2.6. We have 2.6. That's 7. The depth would be 7.9 kilometers. Then 3.2. The depth would be 3.9 kilometers. And then the last earthquake, we have 3.4 Richter, and the depth is 5.5 kilometers. All right, so you don't have to, suppose that the sum of the x's, you don't have to check these numbers, okay? So we're gonna suppose that sum of the x's is 24.1, right? Sum of the x squared is actually 85.75. Sum of the y's is 53.5. Sum of the y squared is 458.31. And finally, sum of the xy is 190.80. All right, so my question for you guys is to compute the R. So question. So you need to compute R, which is, again, just to remind you, the formula, it says n sum of xy minus sum of the x's times the sum of the y. So here the idea is to plug these numbers in the formula, right? So just plug the numbers in the formula. So there's a square root n of sum of the x squared minus parentheses square of the sum of the x's times, so this is multiplication here, and same thing with the y. So sum n times sum of the y squared minus square of the sum of the y's. All right. So please compute R, and you need to say if and determine if the correlation, the linear correlation is between x and y is strong, or so determine if the linear correlation between x and y, x and y is it strong or moderate or low or little, okay? And as the magnitude increase, increases, does the depth of the earthquake increase or decrease? Or decreases. Okay. All right. So I'm gonna give you some time to think about this, guys. Let's say 10. How much time do we have? We have like 20 minutes. Okay, that's good. I guess I can probably solve this problem in 5 minutes. I'm gonna give you like around 15 minutes. So all you have to do, guys, just try, to plug these numbers, these numbers right here, some of the x's, etc., in the formula, as I did in the previous example. Okay.
You said you could solve this problem in 5 minutes.
Well, I mean, well, what do you mean? Like, is it too fast, or 5 minutes is?
That's fast, because I'm just saying, look at all these steps, right? Now imagine this is on the test and we only got an hour and a half.
That's true. I mean, I know.
That's taking up half the test.
No, but I know. I mean, if I do it like in
Oh,
5
we got
minutes.
like 5 questions.
No, but if I do like in 5 minutes, then like in average, I mean, then you would do it probably in like 20 minutes, 3 or 4 times my time.
For me, an hour.
No, no, you're not that. No, that's not true. I don't think that's true. I mean, with the practice, it's not.
My neighbor just told me she's an RN. She was like, she did statistics, like what we're doing. And she was like, my best advice to you is do not try to understand it. Just do the formula. That's what she told me.
The idea
Agree.
is, yeah, I mean.
And she's a smarty pants. Like she's mad smart. She's like extremely like highly intelligent. She used to actually be on the committee of this college on the nursing board.
Okay.
Yeah. All right. Sorry, guys.
I don't know if I know her, but I mean, well, if you know how to apply the formulas, then yeah, then you are fine. But again, it's not just about applying the formulas, but it's to use the formula to, get some information, right? Like we are using this formula of R to say, well, if there is like a relationship between the two, the two variables. So of course, like in this example, like the variable X, that's the magnitude, and the Y is the depth. So using the formula, you can say, well, there is a relation between the depth and the magnitude, or there's no relation between the depth and the magnitude of the earthquake, right? So it's not just about applying the formula, but it's also about, getting some information from the answer from your. Yeah, well, yeah, that's the idea.
Because all my homeworks take me a lot of time. So I'm just imagining. All right.
Well, my advice for you is, because the next week I'm gonna post this review sheet. Of course, you don't have to turn in this review sheet. I mean, it's just for you. But it would be a really good idea to, I mean, if you do the problems in the review sheet and see how much time it's gonna take you to finish the review sheet, because the review sheet is supposed to be like cover everything like the test. So yeah.
In our final, it's going to be like a combination of our test 1 and test 2.
Covers everything. Yeah.
Yeah.
A final is going to be.
Do we have to be timed though? That's crazy. That math is hard.
Well, the final, I think it's more than, I think it's, the final is 3 hours.
It should be 5.
Yeah, I think the final is like 3 hours. Yeah.
They make you time us, Professor?
Oh, yeah.
Or-
No, yeah, of course.
Wow.
Timed, yeah. I mean, it's not like my own policy. I mean, that's like the policy. I mean, that's the department policy. Because
all right, because you know what I'm learning from this class is when I watch the videos and everything like that, and I do the homeworks, for the most part, I get it right, but it takes me so much time, and I'm just concerned that I'm gonna run out of time.
Um, you know, so then it's all about practice.
Yeah.
It's all everything is about practice. It's not just math. I mean, everything. If you do like more than once, like I don't know, two, three times, four times, and the fifth time would be faster than the fourth and the third time, right?
Yeah.
It's all about practice. So again, my advice is um, because the review sheet would be like the test. So my advice is to practice and do the problems in the review sheet and make it, do the problems as fast as possible and
Yeah,
see
no,
if,
I'm gonna do it.
Mhm. Yeah, that would be a good idea. Yeah.
Excuse me, Professor, can you a little bit up because I
Oh
can't
yeah,
see
sure.
the
Okay, up
end.
like this.
No,
Oh, sorry, up. Yeah, sorry.
yeah, I wanna.
Yeah,
Yeah.
the numbers. Yeah. Let me just say, guys, the answer are. I mean, just in case. I mean, if you don't finish this problem now, I mean, you can finish it later. And the answer of R, the R should be 0.511. Right? That's supposed to be the answer. Um, so if you don't get 0.511, then well, I mean, it doesn't have to be like exactly 0.511. If it's very close to 0.511, then that's fine. But if it's very different, then yeah, then you made probably a mistake somewhere. I'm gonna just probably erase this here thing here. So then we can compute R together. So yeah, I mean, the first step is like, you need to know how to plug the right numbers. And then next step, of course, you need to be careful with the operations, the algebraic manipulations. I mean, from this rule. Did anyone got the 0.5? I know it's a very short time, but I'm just curious.
I got the answer, Professor.
Oh, got the answer? Okay. Very good. All right, because we have like just 5 minutes. So let's do this together, right? So R. So first we have N, right? This number N here. What will be N in this example? Any guess?
7.
7. Thank you. So N is 7 because we have 7 data pairs. So N is 7 times. Now, next number. What will be this sum of X times Y? Which number is that? Any guess? What will be this number? Which one?
The 190.18.
Thank you. 190.18. That's the 190.18 minus, and then there's a sum of the x's, right? And sum of the x's, that will be the 24.1, right? Times the sum of the y's, sum of the y's,
53.5.
53.5. Very good. Okay, so that's 24.1 times 53.5. All right, that's the top. Now, the denominator. So we have, again, n, we said it's 7 times. Now, there's this number, sum of the x squared, right? And that will be which number? Any guess the sum of the x squared? That's the, right?
85.75.
85.75. Thank you. So that's 85.75 minus, and then you see there is this parenthesis and there is a square outside. Okay, so just be careful here. You need to write down your parentheses. There's a square outside, and inside there's this sum of the x's, and that will be sum of the x's. That will be this number right here. That's the 24.1. So here it's 24.1 times, and now we do the same thing with the y. So there's a 7 again times of the y squares, right? That's this number right here. So that's a 458.31. 0.31 minus, and then there is a parenthesis and square, and inside it's, as you can see, it's inside the parentheses is the sum of the y's. Sum of the y's is this number right here. right? The 53.5. So of course now, so first in the top, you need to multiply those numbers right here. You know, the 7 times 190.18 minus, and then you multiply two numbers right here, the 24.1 by 53.5, right? So, so for example, let me just check my notes. So for example, 7 times 190.18, that will be equal to 1,300, sorry, 31.26, right? Minus, and then this is 24.1 times 53.5, right? So times 53.5, and that will be equal to 1,289.35 over, right? Then we have this square root. So there is this number right here, 7 times 85.75, right? So we need to multiply 7 by 85.75. So that will be equal to 600. So this is 600.25 minus, and then there's this 24.1 square. So we do 24.1 times 24.1, right? So that will be equal to actually 580.81. Of course, there's a square root right there, right? That's the first square root. Now the second square root. So first we have a 7 times this 458.31, right? So it's 7 times 458.31. So that'll be equal to 3,000. So that's 3,208.17 minus, and then there is this square, right? There's this 53.5 square, so that's like 53.5 times 53.5. So and that'll be equal to 2,862.25. Right. Now we can subtract. We can finish the top. So we can subtract the 1,331.26 minus this 1,289.35. So that will be 41.91 over. And just give me 1 minute, guys. I'm gonna be done in a minute. So we have 600. 600.25 minus 580.81. So that's actually 19.44 times. There is this 3,208.17 minus the 2,862.25, so that'll be equal to 345.92. Now you need to take the square root, and then we're almost done. So there's this 41.81 in the top. Take the square root. So you have the square root of this number. So square root of 19.44. So that'll be equal to 4.40 times, and then we have this square root of 345.92. That will be 18.6 or 59, I think, right? And then, well, we are done. So that's 49.91 times this 4.40 right, times the 18, that's 81.72, I think. And then, yeah, and then the answer, that's exactly the 0. We said 511. Okay. Anyway, so yeah, so that's the answer. And from that, you can say, so the is positive, and it's not close to 0, it's not close to 1, it's actually close to 0.5, so close to 0.5. And when it's close to 0.5, then we have moderate linear correlation. Linear correlation. All right, guys, I'm gonna stop here. Thank you for listening, and yeah, I will see you tomorrow, right? So I guess we are done with this section, and yeah, and then I guess tomorrow we can move to the next one. All right, thank you, everyone, and I will see you.
All right, thank you, Professor.
All right, bye, everyone.
All right, bye, Professor.
Ariani. Oh, thank you, Ariani. Yep, I got you. Thank you. Let me just write down.
Professor,
Yes.
I don't know if you got my name when you took the attendance.